dash 2 open, but also get out that flow chart. I'll call it your reference chart, because you have it on the shape of things you can about that. Get this out too, because this is the data we're going to be doing with these. These are, what do you think the name is of these shapes? Mainly quadrilateral. They're squares, but that's only one of them, right? They're rectangles, that's only one of them. But all of them are quadrilaterals. So that's going to be our quadrilateral family. We picked them up on Monday. The little reference charts. And we're going to fill this in little by little as we know the properties that we need. So, a quadrilateral, for our first word here, is how many sided? 4-sided figure. Here's a theory you need to know. And it actually comes from what you already did Monday and yesterday. That the sum of the interior angles of a quadrilateral, 4-sided, you did this several times over the past 2 days. It was 4 minus 2 was 2 times 180. It always will come out to 360 degrees. So for a quadrilateral, the angles all add up to 360. For a triangle, they all add up to 180. Okay, so let's deal with what we know already about quadrilaterals. We know 2 things. Take your chart, and it's a flow chart, which means everything on top flows down to everything else as well. So if a quadrilateral has 4 sides, then everything that comes out of a quadrilateral also has 4 sides. The property that I'm going to say about quadrilaterals is that the interior angles always equal 360. And that's true for everything in the quadrilateral family. Alright, so for parallelograms, keep your flow chart out right there. We're going to look at some specific ones, and when we know it, we'll add it to our flow chart. So parallelograms. These have one definition, and then they have 4 special properties. A parallelogram is a quadrilateral with both pairs of opposite sides. Alright, it's called a parallelogram. So what do you think they're going to say there? Both pairs of opposite sides are what? Parallel. Parallel. Good. Parallel. The definitions they try as best as they can to make it logical to what the definitions are. A quadrilateral with both sides of opposite sides are parallel. Okay? So the opposite sides are AD is parallel to BC. And you could say AD is parallel to BC. Those are part of the definition. Anytime you know you have a parallelogram, this is absolutely true. But it also has to be true that AB is parallel to which one? Yeah, and notice that those have matching arrows, but it's different than AD and BC. So AB is parallel to DC. Okay, so that's what makes a parallelogram a parallelogram. But the opposite sides are parallel. Now there's other things that are true, but this is the definition. So if you were doing a proof or anything, and you needed to use a definition of a parallelogram, that's what this one would be. Opposite sides are parallel. Now these theorems are properties. They're rules that are true, but it's not what makes a parallelogram a parallelogram. Alright, so just let me give them to you and then we'll study them over and over. Opposite sides of a parallelogram. I already know they're parallel because it's a parallelogram, but it's also true to say that opposite sides of a parallelogram are congruent. Opposite sides are equal to each other. Only if you already know it's a parallelogram. Alright, so, in other words, even though it has the arrows, that doesn't mean congruent. We have to mark it with a congruent sign. AD is congruent to BC, and AB is also congruent to DC. DC, and then we have AD is congruent to BC. Opposite sides are congruent. Look at the next one. How does that change? Opposite what? Angles are congruent. So that's another rule that's always true. Opposite angles are congruent. So angle A would have to be congruent to what angle? C. Opposite angles, whenever you have a parallelogram, the opposite angles are congruent. So angle A is congruent to angle C, and angle B is congruent to angle D. Okay, now these are going to help you when it comes to problem solving time, but you have to know the properties before you can use it. All right, questions on those? All right, let's keep going. You have another rule, consecutive. Do you remember what consecutive means? In a row, same side, right next to each other, nothing in between them. Good. So consecutive or same side angles of a parallelogram are, let me give you the hint, same sides are what? Supplementary, yep. Because we're dealing with a parallelogram, that means we're dealing with all but a whole bunch of parallel lines. So if you can find the same side interior angles, supplementary, then you have supplementary angles. So measure of angle A plus the measure of angle D. If you add A plus D together, how many degrees should you have? 180. Same side angles are supplementary. You get 180 degrees. And A plus B would be 180. And B plus C would be 180. And C plus D would be 180. Okay? And the last rule that you need to know is that in a parallelogram, the diagonals of a parallelogram bisect each other. That means that every diagonal got cut exactly in half right down the middle. So let's draw the diagonals first. In this one right here, a diagonal doesn't go from A to D, that's a side. A diagonal has to go to a vertex that's not next to it. So draw a diagonal AC. What would another diagonal be? From what letter to what letter? From B to D. So every parallelogram, every quadrilateral can have diagonals, but in a parallelogram, it's special because the diagonals bisect each other. So this half is equal to this half. That one got cut right down the middle. Basically, this plane right here is a midpoint. And then this half is also equal to this half. Okay, that's a very important rule from parallelograms that you're going to be using over and over and over again. Diagonals cut each other in half. Any questions? All right. So go to your chart, please. Let's fill this in. Everything we know about parallelograms now. I want you to be careful as you're taking notes. So of course, when I collect them, I want to make sure nothing is blank, but also this chart especially, keep it organized. You're going to be able to use some things on the test this time. So make sure that everything is accurately filled in, but no cheat notes down the sides of them. Right? Only your regular notes. Well, that's why I'll be collecting them. If I see the cheat notes, then that'll affect everything. Parallelogram. First thing we're going to say every time is the exact definition, not just the rules. What makes a parallelogram a parallelogram? The sides are what? No, look at the word parallelogram. What are they? Sides are parallel. Good. Opposite sides are parallel. The opposite sides are equal. That's true, but that's not the definition of it. That's just something that comes out of it. So in the parallelogram, you guys found the right place, didn't you? Opposite sides are parallel. So I have these boxes in here so you know about how many we need to fit, so you can make your writing appropriate to be able to fit 4 more things in. Okay, I already heard someone say opposite sides are congruent, and that's true. These are just properties now. Things that are true about parallelograms. Opposite sides are congruent. What else is true about parallelograms? Okay, we know that the opposite sides are parallel and the opposite sides are congruent. What else is true about parallelograms? Opposite angles are congruent, I heard. Okay? And then I heard someone say supplementary. What's that rule? What does it say about supplementary? The same side angles, the angles next to each other are supplementary. That's right. Whoops, sorry. Wrote that one out of order. Here we go. Consecutive or same side angles, consecutive means same side, are supplementary. Those are the angles next to each other instead of across from each other. And what was the last rule? consecutive or same side, the ones next to each other. And the last rule, diagonals do what? Bisect each other. Whenever you draw two diagonals in a parallelogram, they cut each other in half. Okay, these are your 5 most basic. And everything we can study that is a part of the parallelogram family, it's all going to have these same rules. And once we finish the chart, then we'll look at all the relationships between them. Okay, so let's look at a few examples. But turn the page and look at this one right here. I'm going to start you off on a couple, and then I want you to finish them. Actually, I have it on my All right, maybe I'll finish this. It's a different rule. So I don't really discuss All right, use a diagram of a parallelogram. It tells you it's a parallelogram. That means that you already know the opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, same side angles are supplementary, and diagonals bisect each other. So I don't have that up on the board, but you guys have all those properties written in your flow chart, in your reference chart right there. So keep that out right in front of you as we look at these. Okay, so the question is, we need to figure out what would fill in the blank. So it says that MN is congruent to. So let me mark MN. MN is right here. That's on that side. What rule would you use here to find what's congruent to it? Opposite sides are congruent. That's right. So it's congruent to PO. MN and PO are opposite sides. So MN is congruent to PO. Opposite sides congruent. Let me try to make that smaller. Opposite sides congruent. Okay. So now let's go over to, well, let's just go down this road. ON. You got the answer already? O, is that the O right there? Okay. I can't see the difference between the O and the Q. O-N, I want to do it in a different color. O-O-N, so it's up that way. O-N. That one is congruent to which one? P-N, because opposite sides are congruent. Let's see. Same reason, opposite sides congruent. All right, let me do some of the ones with angles for you. Angle MQN. MQN. This angle right here, angle MQN, is congruent to what angle? PQ what? Excellent. PQO. And that's from an old reason. Does anybody remember the name of that reason? Excellent. Vertical angles are congruent. So it uses old rules. And since this is a parallelogram, you know there's going to be what kinds of angles come out of parallelograms? We said this. We said every time there's parallelograms or parallel lines, you always look for one type of angle. What was that? From parallel lines? Alternate interior angles, okay? That's what you look for. You might also see some corresponding angles, but not so much in parallelograms. Okay, so I'm going to do one more, and then I want you to try these. Let me try, I think you guys can do that one. Let's do letter G. QM. QN is congruent to which one? QO, good. QM is congruent to QO, and the reason for that? Diagonals bisect each other. All right, in a second, I'm going to ask you to come back and finish this, but I want to look at a couple from the bottom as well. Because this is all about properties. The next one is going to be about numbers, finding actual numbers in relation to it. So in this case, we know it's a parallelogram. HIJK, and we're supposed to find the missing parts now. They want me to find HI, the length of HI. Well, HI is a side. So when I do these kind of problems, let me just tell you the way that I handle it. I ask myself, is this a rule about sides or angles or diagonals? Those are the three things. Okay, so this is a side. So my rule about sides is that opposite sides are congruent, so what would HI have to be? Okay. This is a rule about the sides. Let's find a rule that's talking about angles. J. See this 84 right here? That line is going all the way across, so 84 is the whole thing. So let's do letter P. Find the measure of angle JIH. Okay, we want to know this one right here. Any ideas? Good. Let me go through my steps. I ask myself, is this a side, an angle issue, or a diagonal issue? It's an angle. It's an angle issue. Okay, so I think about my rules. Opposite angles are congruent and same sides are supplementary. So what I'm dealing with here is two angles that are on the same side. This one's not really an angle because it stops right here at the line. So you do 180 minus 84, then 96. Can you help me out? Is that 96? Correct me if I'm wrong, please. Same side interior angles are supplementary. So then I'm going to let you play around a little bit. Remember, there are alternate interior angles. If this is 28, go to the opposite side and to the other corner of the transversal. That one's going to be 28 as well. All right, so go ahead and take about 5 minutes while I stamp your homework, and you go just the top two sections down to letter Q, okay?